Hey there, so we've all gotten used to these incredibly powerful single AIs, right? But what if the next big thing, the real game changer, isn't just one even smarter AI, but a whole team of them working together? That's what we're diving into today.
And that really brings us to the big question, doesn't it? Is one super smart AI, no matter how brilliant, really enough to tackle the world's most complex problems? I mean, think about things like developing new medicines or figuring out climate change. These are huge, multi-layered challenges. It kind of feels like we're starting to hit a wall with what a single lone genius can do on its own.
And this is where the big shift in thinking is happening. You've got the old way, the monolithic AI, that's our lone genius trying to be an expert in absolutely everything. And then you've got the new way, the multi-agent AI. Think of it like putting together a dream team. You've got specialists, each a pro in their own field, all collaborating. It's not about one AI doing everything. It's about the right AIs doing the right things together.
Okay, so let's get into it. Why do we even need this shift? I mean, these lone genius models are pretty amazing, right? So why are they starting to hit their limits?
Well, it comes down to a few key problems. First off, scalability. A single AI can only do one thing at a time, so it becomes a huge bottleneck. Then there's the reliability risk. If that one model fails, your whole system just stops, dead in the water. But the biggest issue, really, is its limited reasoning. It's incredibly hard for one AI to be a world-class data scientist, a brilliant creative writer, and a sharp market analyst all at the same time. For those really complex jobs that need all those skills, it just struggles.
So if the lone genius has its limits, the obvious next question is, how do you actually build this AI dream team? How do you get them to work together? Let's take a look under the hood.
It's actually a pretty elegant idea. A multi-agent system is basically just that, a team of specialized AIs. You might have one agent that's a researcher, another that's a writer, maybe a coder agent, and they all collaborate on a single goal. The core idea, and this is the magic of it, is that the intelligence of the team is way, way greater than what any single agent could ever achieve on its own.
But how do they stay organized? How do they not just trip over each other? Well, the most common approach is something called the orchestrator-worker pattern. Think of the orchestrator as the team's project manager. It gets a big, complex request from a user. Say, write a complete market analysis on the future of electric vehicles. The orchestrator doesn't do the work itself. Instead, it breaks the job down and delegates. It tells the researcher agent to go find all the latest data, the analyst agent to crunch the numbers and find trends, and the writer agent to draft the report. They all work at the same time, in parallel, which is super efficient. Then they send their finished pieces back to the orchestrator, who puts it all together into one polished final answer. Brilliant, right?
Okay, this is where it gets really, really cool. Because these AI agents don't just work together, they actually learn from each other. This is the leap from just being a well-managed team to becoming something with true collective intelligence.
One of the key ways they do this is through something called knowledge distillation. It's exactly what it sounds like. You have a skilled teacher agent, one that's an expert in something, and it literally transfers its knowledge to a student agent. And get this, the results are incredible. Studies have shown this can boost accuracy by over 20%. And maybe even more importantly, it helps slash those weird AI hallucinations because the knowledge is being passed down from a trusted, proven source.
Then you have multi-agent reinforcement learning, or MARL for short. The best way to think about this is like a sports team practicing together. The agents learn through trial and error. They try out different plays, and when an action helps the team get closer to its goal, it gets a reward. It's a positive reinforcement loop. And over thousands of these trials, they start to develop these really sophisticated collaborative strategies all on their own. It's like watching a basketball team go from a bunch of individuals to a perfectly coordinated unit.
And the third big method is imitation learning. This is probably the one that's most familiar to us. The agents just learn by watching. They observe an expert, either another AI or even a human, perform a task successfully, and then they try to mimic that behavior. The student agent watches the teacher, learns to replicate the process, and then over time even starts to find ways to improve on it. It's a super fast and effective way to get a new agent up to speed.
So all this theory about learning and collaborating is fascinating. But you might be wondering, is anyone actually using this stuff, or is it all just in a research lab somewhere? Well, the answer is a resounding yes. The AI workforce is not coming. It's already here. Let's look at the proof.
And I mean, look at this number.
60%. That's how many Fortune 500 companies are already using Crew AI, which is the leading platform for building these multi-agent teams. 60%. This isn't some niche experimental tech anymore. It has exploded into a core tool for the biggest companies in the world.
And Crew AI isn't alone. It's part of a growing ecosystem. You've got AutoGen from Microsoft, which is awesome for more flexible, research-style projects. And then there's LangGraph, which is a beast at handling really complex workflows that need a lot of feedback and cycles. So depending on what kind of AI team you're trying to build, there's a tool out there for you.
And the real-world applications are just popping up everywhere. Think about customer service, right? Instead of one chatbot trying to answer everything, your question gets instantly routed to the perfect specialist agent. In healthcare, you have teams of AIs working together to analyze medical data to help doctors with diagnostics. We're seeing it in finance for fraud detection, in marketing for creating entire campaigns. It's just everywhere. These AI teams are fundamentally changing how work gets done.
So, where does this all go? What's the end game here? Let's zoom out and look at the future, both the incredible potential and the very real challenges that are still ahead.
The ultimate goal, the holy grail, if you will, is something called artificial collective intelligence, or ACI. And this is so much bigger than just making things faster or more efficient. This is about creating a system where the intelligence of the whole is truly greater than the sum of its parts. It's about emergent intelligence. That's where the team, through collaboration, starts to develop brand new skills and insights that nobody ever explicitly programmed into them. It's mind-blowing to think about.
But we have to be realistic. We're not there yet. There are still some major hurdles to clear. We have to nail down reliability and make sure these agents stay grounded in facts. We need to figure out how to manage the chaos when teams grow from 10 agents to 10,000. And the biggest one of all, safety and alignment. How do we make absolutely sure that the team's goals always stay aligned with our human values? These are the tough problems that the brightest minds are working on right now.
So here's where we are. We are actively building AI systems that are learning how to collaborate, how to communicate, and how to solve problems as a true team. So I want to leave you with this one final thought to chew on. When these AI teams get better at collaborating than we humans are, what happens then? What massive, seemingly impossible challenges in science, in medicine, in our society finally become solvable?